All right, 24 through 27, we're using basic trig. 24 and 25 are basically typing these into your calculator. Make sure you're in degree mode. If you press mode, see the third line down, make sure you're in degrees. Make sure that's darkened and highlighted. If that's the case, 24, it's a matter of just typing 72 degrees in your calculator. Don't even need to type the degree symbol. Cosine of 38 and tangent of 54, so you get these long, non-repeating decimals. So there you go. Now, as far as 25 goes, what you want to do is you want to find an angle. So what you're going to need is an inverse. So really for letter A, if you take the sine inverse of each side, what that does is on the left side, sine inverse cancels out sine. So really you're left with A is going to be whatever the inverse of 0.97437 is going to be. So I'm typing that into my calculator, but I'm looking for an angle, so I got to use that inverse. So I'm going to go 0.9745, and that's going to come out to about 77 degrees. Same concept for letter B. If I want cosine to go away, I use the inverse. And I'm going to get an angle after that. So angle B is going to be whatever cosine inverse of 0.98163. So that's going to round to about 9. Oh, I made a mistake there. Let's try that again. I typed in the wrong number, so we want 9.98163. Let's see how big of a difference that makes. It's going to come out to about 11. On the last one, again, we're going to do the inverse tangent. Tangent inverse knocks out tangent. So I do tangent inverse of both sides there. So if I go my second tangent to get my inverse of 1.2799, we're going to get 51.9 repeating, so we're going to go ahead and call that 52. Now, when we want to start applying these problems, we're going to have to start setting up the ratios ourselves. So for like number 26, if I want the sine of C, cosine of C, tangent of C, in order to write these, remember we're going to use SOHCAHTOA. That's going to tell us sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. I'm going to need all three sides of the triangle. In this case, I could use Pythagorean theorem to find the missing side, or if I think back to my triangle families, if I have 15 and 17, this missing side is going to be 8. Now it's a matter of establishing which sides are opposite, adjacent, and hypotenuse. 26, I'm basing my names off of angle C. So I know the hypotenuse is always across from the right angle. The opposite side, I'm going to pass through the triangle, come out the other side, and that's my opposite side, my opposite leg. And the adjacent leg is the side that's connected. Angle C is connected to two sides, but 8 is the leg and 17 is hypotenuse, so the adjacent leg would be 8. In this case, sine is opposite over hypotenuse. So in my picture here, it's going to be 15 over 17. For cosine, that's adjacent over hypotenuse. That's going to be 8 over 17. And then for tangent, that's going to be opposite over adjacent. So in this case, it's 15 over 8. How the problem changes for number 27, well, it changes my reference angle. My reference angle is H. So that makes 8 my opposite leg. It makes 15 my adjacent leg, which I'll label, and 17 my hypotenuse. So in this case, sine of H, opposite over hypotenuse, 8 over 17. Cosine is adjacent over hypotenuse, so that's 15 over 17. And then tangent is going to be opposite over adjacent, which is going to be 8 over 15.